Vue.js, the practical guide to building modern web applications. Chapter 1, Welcome to the world of Vue.js, what it is and why you'll love it. 1.1, the evolving web landscape and the need for frameworks. The journey of web development has been a fascinating evolution. In its earliest days, websites were largely static documents, much like digital brochures. You'd write some hypertext markup language, or HTML, to define the structure and add a sprinkle of cascading style sheets, CSS, to make it look decent. Interactivity was minimal, often limited to simple links or forms that would reload the entire page upon submission. As the internet matured, users began demanding richer, more dynamic experiences. This led to the rise of server-side scripting, where languages like PHP or Ruby would generate HTML on the server before sending it to the browser. This offered more personalization and database interaction, but every user action, like filtering a list or submitting data, still often meant a full page refresh. Then came JavaScript, allowing for client-side interactivity. Suddenly, parts of a page could change without a full reload. Tools like jQuery made it easier to select elements and manipulate the document object model, or DOM, the browser's internal representation of your web page. While revolutionary, relying solely on JavaScript to manually update every piece of dynamic content, manage complex states, and organize large code bases quickly became overwhelming. As applications grew, this approach led to what developers call spaghetti code, a tangled mess that was hard to maintain, debug, or scale. This complexity gave birth to modern JavaScript frameworks. These powerful tools emerged to provide structure, patterns, and efficiencies that allow developers to build sophisticated, interactive web applications with greater ease and maintainability. They tackle common challenges like managing data, organizing code into reusable pieces, and efficiently updating the user interface. Or UI 1.2, what exactly is Vue.js? In this world of evolving web development, Vue.js stands out as a progressive JavaScript framework specifically designed for building user interfaces. But what does progressive really mean? Think of it this way. Vue.js is incredibly approachable. You don't have to commit to building your entire application with Vue from day one. You can start small, perhaps by adding a little interactive widget to an existing web page, like a dynamic search bar or a simple image carousel. You can simply include Vue as a small library, and it immediately enhances that specific part of your page. However, Vue is also powerful enough to scale up to massive, complex single-page applications, often called SPAs. SPAs are web applications that load a single HTML page and then dynamically update its content as users interact with it, creating a fluid, app-like experience without constant page reloads. The progressive nature means you can gradually adopt more of Vue's features and ecosystem as your project grows and its needs expand. It offers great flexibility, allowing you to use as much or as little of the framework as your project requires. At its core, Vue.js champions a few key characteristics: declarative rendering. Instead of telling the browser how to change elements step by step, e.g., find this div, change its text, then change that image's source, you tell Vue what you want the final UI to look like based on your application's data. Vue then handles all the complex DOM updates behind the scenes. Component-based architecture. Vue encourages you to break down your user interface into small, self-contained, reusable building blocks called components. Imagine your web page is a Lego set. Each Lego brick is a component, like a navigation bar, a product card, or a button. You build these individual pieces once and then combine and reuse them throughout your application, making development more organized and efficient. Reactive updates. This is one of Vue's superpowers. When you declare data in your Vue application, Vue makes it reactive. This means if that data changes, for example, a user types into an input field or new data arrives from a server, Vue automatically and efficiently updates only the necessary parts of the user interface that depend on that data. This dramatically simplifies the process of keeping your UI in sync with your application's state. 1.3, why choose Vue.js? Key benefits. With numerous JavaScript frameworks available today, each with its strengths, why might Vue.js be the right choice for you? Approachability and ease of learning. Vue is renowned for its gentle learning curve. Its API, Application Programming Interface, is intuitive, its documentation is clear and comprehensive, and its core concepts are easy to grasp for anyone with a background in HTML, CSS, and basic JavaScript. Many developers find the structure of a Vue application, particularly its single-file components, which combine HTML, JavaScript, and CSS for one component in a single file, familiar and straightforward. Performance: Vue is lightweight and highly optimized. It boasts an efficient virtual DOM implementation, a programming concept where a virtual representation of the UI is kept in memory and synchronized with the real DOM, which minimizes the number of actual changes to your web page, leading to fast initial renders and snappy updates. Flexibility: while offering powerful conventions, Vue isn't overly opinionated. It provides sensible defaults, but gives you the freedom to integrate with a wide range of libraries and tools based on your project's specific needs. This flexibility means you have control over your architecture without being shoehorned into a single way of doing things. Exceptional developer experience, DX. Vue focuses heavily on making developers productive and happy. Its official tooling, like Vite, a modern build tool, and the Vue Dev Tools browser extension, allows for rapid development, clear debugging, and insightful performance monitoring. The error messages are typically very helpful, guiding you directly to problems. Versatility: thanks to its progressive nature and robust ecosystem, Vue can be used for a vast array of projects. From small interactive widgets embedded in a traditional website, to large-scale single-page applications, to static websites, with frameworks like Nuxt.js, and even mobile applications, using native script view and desktop applications, with Electron. 1.4 A quick look at Vue in action, conceptual. To truly appreciate Vue, let's explore its core ideas without diving into specific technical details just yet. Imagine building a simple application, perhaps a to-do list. In a traditional setup, if you wanted to display the number of pending tasks, you'd constantly have to write code that finds the HTML element showing the count and then manually updates its text every time a task is added or completed. With Vue, it's far simpler. You declare a piece of data called pending tasks count in your application. Then, in your HTML, you'd insert a special placeholder, something like pending tasks count, exactly where you want that number to appear. Vue takes care of the rest. When your application's logic increments pending tasks count, the number displayed on the page magically updates automatically. You, the developer, don't need to manually tell the browser to change the display. You just update the data, and Vue handles the UI synchronization. Now, consider building that to-do list application. It will have many parts: an input field to add new tasks, a list of individual task items, perhaps a filter for completed tasks, and a button to clear all tasks. Instead of creating one giant HTML file and trying to manage all this complexity, Vue encourages you to break it down. You might create a task item component for each individual task in the list, a task input component for the input field, and a task list component to manage the collection of task items. Each of these components is a self-contained unit with its own logic and appearance. You build them once, and then you can reuse them throughout your application, making your code clean, modular, and much easier to understand and maintain. This Lego block approach to building user interfaces is a fundamental concept in modern web development, and Vue excels at it. 1.5 Vue.js in the real world. Vue.js is not just a theoretical framework. It's a practical, widely adopted tool used by a diverse range of companies and developers worldwide. From agile startups to established enterprises, development teams leverage Vue to build everything from interactive dashboards and data visualizations to complex e-commerce platforms and content management systems. Its flexibility allows it to power applications that demand high performance, rich interactivity, and an excellent user experience. Its gentle learning curve makes it particularly appealing for teams that need to quickly onboard new developers or those looking to transition from older technologies to a modern framework. The robust tooling and active community ensure that developers have the support and resources they need to build and maintain sophisticated web applications efficiently. 1.6 What you will learn in this book. This book is designed to be your comprehensive, practical guide to building modern web applications with Vue.js. Starting from the very beginning, we will move step by step through the process, setting up your development environment, understanding Vue's core concepts, and then gradually building up to more advanced application patterns and ecosystem tools. Our journey will cover setting up your development environment for optimal Vue.js development, the fundamental concept of reactivity and how Vue keeps your UI in sync with your data, building applications using the powerful component-based architecture, managing data between components and across your entire application, handling user input and creating interactive forms, connecting your application to external data sources and APIs, navigating between different views in a single-page application, strategies for testing your applications to ensure quality and prevent bugs, preparing and deploying your application for the world to see. By the end of this book, you will have a solid understanding of Vue.js and the confidence to build your own robust, interactive web applications. Before we dive in, please note that while this book will explain Vue.js concepts from the ground up, it assumes you have a foundational understanding of web technologies: HTML for structuring web content, CSS for styling, and basic JavaScript for programming logic. Familiarity with concepts like variables, functions, objects, and arrays in JavaScript will be particularly helpful. If you're a bit rusty on these, a quick refresher before proceeding will set you up for success. Are you ready to embark on this exciting journey into the world of front-end development with Vue.js? Let's begin. Chapter 2. Setting up your Vue.js workshop, tools and environment. 2.1 The importance of a well-prepared workshop. Building a web application is akin to crafting something intricate in a physical workshop. Just as a carpenter needs specific tools like saws, drills, and measuring tapes, a web developer requires a set of digital tools to write code, manage dependencies, and run their applications. Having a properly set up development environment is not just a convenience. It is fundamental to an efficient and enjoyable development process. A well-configured workshop ensures that your code runs consistently, that you can quickly test your changes, and that you have all the necessary utilities at your fingertips. For Vue.js development, this means having the right runtime environment, a capable code editor, and the specific tools Vue uses to streamline project creation and deployment. 2.2 Node.js. The foundation. At the heart of modern JavaScript development, including most Vue.js projects, lies Node.js. Although Vue.js applications run inside a web browser, many of the tools we use to build and manage these applications run on Node.js. Think of Node.js as a JavaScript runtime environment that allows you to execute JavaScript code outside of a web browser. For example, directly on your computer's operating system. Node.js comes bundled with a critical tool called NPM, which stands for Node Package Manager. NPM is a vastly popular command line utility for managing software packages or libraries that your project depends on. When you hear developers talk about installing dependencies, they're most likely referring to using NPM or a similar tool like Yarn, which we'll discuss briefly. To get started, your first step is to install Node.js on your computer. You can find installers for Windows, macOS, and Linux on the official Node.js website. It's generally recommended to download the LTS, long-term support version, as it offers the highest stability. Once installed, you can confirm its presence by opening your computer's command prompt or terminal and typing a simple command to check the Node.js and NPM versions. If you see version numbers displayed, you're all set. An alternative to NPM for package management is Yarn. Yarn is another popular package manager that offers similar functionality, often with performance improvements or a slightly different command syntax. Many developers use them interchangeably, and the commands we'll discuss are typically available in both. For the purpose of this book, we'll primarily refer to NPM commands, but know that Yarn equivalents usually exist. 2.3 Your code editor, the crafting bench. While you could theoretically write code in a basic text editor, a specialized code editor is crucial for productivity. These editors offer features like syntax highlighting, coloring different parts of your code to make it readable, intelligent auto-completion, suggesting code as you type, error detection, and integrated terminals. For JavaScript and Vue.js development, Visual Studio Code, VS Code, is overwhelmingly popular and highly recommended. It's free, open source, and incredibly versatile. In addition to its core features, VS Code supports a vast ecosystem of extensions that can further enhance your Vue.js development experience. Key extensions often include Volar, the official language support for Vue.js, providing excellent syntax highlighting, IntelliSense smart code completion, and type checking for Vue files. EaseLint helps enforce code style guidelines and catches potential errors early. Prettier, an opinionated code formatter that automatically tidies up your code to a consistent style. Downloading and installing VS Code is a straightforward process from its official website. Once installed, you can explore and add extensions directly from within the editor. 2.4 Vite. The modern project scaffolding. In the world of JavaScript frameworks, tools exist to quickly scaffold or create a new project with all the necessary files and configurations set up. Historically, for Vue.js, this role was often filled by the Vue CLI command line interface. However, in recent years, a newer, faster build tool and development server called Vite has become the recommended choice for starting new Vue.js projects. Vite, pronounced vite, like vite in French meaning quick, stands out because of its incredible speed during development. Instead of bundling your entire application before serving it to the browser, Vite leverages native JavaScript modules directly in the browser's import system. This means that when you're developing, only the code needed for the current screen is processed, leading to near-instantaneous server startups and lightning-fast, hot module reloading, where changes you make in your code appear in the browser almost immediately without a full page refresh. For most new Vue.js projects, Vite will be your go-to tool. 2.5 Creating your first Vue.js project. With Node.js and a code editor installed, you are ready to create your first Vue.js application using Vite. This is typically done through your computer's command, prompt, or terminal. The general approach involves running a command that tells Node.js's package manager, npm, to create a new Vue project using Vite. You'd specify a project name, and Vite would then guide you through a few simple choices, such as whether to include TypeScript support or basic testing configurations. For now, you can keep these choices simple, opting for standard JavaScript and no additional features. Once the command finishes, Vite will have created a new folder in your specified location with the project name you provided. Inside this folder, you'll find the complete foundational structure of a Vue.js application. 2.6 Exploring the project structure. Let's take a conceptual tour of the files and folders Vite creates for a new Vue.js project. Understanding this structure will help you navigate your application as it grows. Node modules/. This directory contains all the external JavaScript libraries and packages that your project depends on. npm manages this folder, installing everything specified in your package.json file. You generally don't need to interact with files within Node modules directly. Public/. This folder is for static assets that are directly copied to the build output without any processing. This might include your index.html file, images, or other assets that are simply served as is. src/. This is the heart of your Vue.js application, where all your actual development work will happen. Inside src, you'll typically find assets/, a place for static files that will be processed by Vite, such as images, fonts, or globally used style sheets. Components. This directory will house your reusable Vue components. As we discussed, components are the building blocks of your application, like buttons, navigation bars, or data display modules. App Vue. This is usually the root component of your Vue application. Think of it as the main container for your entire interface. Main.js or main.ts if using TypeScript. This file is the entry point of your application. It's where Vue is initialized and mounted to the index.html file, kicking off your application. Gitignore, a file used by Git, a version control system, to specify which files and folders should be ignored from being tracked, such as node modules. Index.html, the main HTML file that your web browser loads. Your Vue application will mount itself into a specific element within this HTML file, usually a div element with an id of app. Package.json, this is an incredibly important manifest file. It holds metadata about your project, such as its name and version. Crucially, it lists all the project's dependencies, the libraries it relies on, and defines scripts, shorthand commands that automate common tasks like starting the development server or building the application for deployment. Vite.config.js. This file contains the configuration for Vite, allowing you to customize how your project is built and served during development. README.md. A markdown file that typically contains a description of your project, instructions for setup, and usage. 2.7 Running your application. Once your project is created and the files are in place, the next step is to make sure all the necessary project dependencies are installed. You can do this by navigating into your project folder, using your terminal, and running a simple npm command that instructs the package manager to read the package.json file and download all the listed dependencies into your node modules folder. After the dependencies are installed, you can start your development server. This is also done with a simple npm command, often specified as a script in your package.json file. When you run this command, Vite spins up a local web server, typically on your computer at an address like localhost:5173, processes your Vue files, and serves them to your browser. You can then open your web browser and navigate to the provided address to see your Vue.js application running live. This development server is smart. Any changes you save in your code editor will instantaneously appear in your browser, thanks to Vite's hot module reloading. This rapid feedback loop is a key part of the enjoyable developer experience with Vue.js and Vite. With your workshop set up and your first basic Vue application running, you're now ready to start building. In the next chapter, we'll dive into the core concepts of Vue.js, learning how to display dynamic data and respond to user interactions. Chapter 3. Your first Vue.js application. The core concepts. 3.1 The Vue application instance. Your application's heart. Every Vue.js application begins with what's known as an application instance. Think of this as the main entry point to your Vue-powered interface, the central control hub that manages all the dynamic behavior and data for a specific part of your web page. To bring a Vue application to life, you first need to create this instance. You do this by calling a function that creates a new Vue application. Once created, this instance needs to be told where on your existing HTML page it should take control. This process is called mounting. Typically, you'll have a simple HTML element, often a div, with a unique identifier, an id, like ID equals app. You instruct your Vue application instance to mount itself to this element. From that moment on, Vue takes over managing everything inside that specific HTML element and brings it to life with dynamic content and interactivity. Any content within this designated HTML element will now be under Vue's intelligent control. This setup means your Vue application doesn't necessarily have to take over the entire web page. It can be confined to a specific section, allowing you to gradually introduce Vue into an existing project, or even have multiple independent Vue applications running on different parts of the same page. 3.2 Managing data. The data option. One of Vue's fundamental strengths is its elegant approach to managing dynamic information. In every Vue application or component, there's a special area where you declare the initial state of your application's data. This data includes all the variables, properties, and values that your application needs to display or use, such as a user's name, account, a list of items, or whether a button should be enabled. When you define properties within this data section, Vue works its magic. It transforms these ordinary JavaScript properties into what are called reactive properties. This means that Vue constantly monitors them for changes. The moment a value within your reactive data changes, Vue intelligently detects it and automatically updates all the parts of your user interface that depend on that specific piece of data. This automatic synchronization is a cornerstone of Vue's efficiency and ease of use. You, the developer, no longer need to write complex code to manually find HTML elements, update their text content, modify their styles, or change their attributes every time your application's underlying data shifts. Instead, you simply update the data properties, and Vue handles the complex process of reflecting those changes on the screen, ensuring your user interface always remains consistent with your application's current state. 3.3 Displaying dynamic information. Text interpolation. One of the most immediate benefits of using a framework like Vue.js is its ability to effortlessly display and update dynamic information on your web page. Imagine you have a price for a product, a count of items in a shopping cart, or a welcome message for a user. In traditional web development, if these values changed, you'd constantly be writing JavaScript code to find the specific element on the page and then update its text content. Vue simplifies this dramatically through a concept called text interpolation. To tell Vue where to display a piece of your application's data, you use a special syntax within your HTML. This syntax looks like two opening curly braces followed by the name of your data property, and then two closing curly braces. For instance, if you have a piece of data named product name, you would type product name directly into your HTML where you want the name to appear. Vue will automatically look up the product name value from your application's data and replace that product name placeholder with its current content. The real power of this mechanism shines when that data changes. Unlike static HTML, where you'd need to manually intervene, Vue's ingenious reactivity system, which we'll explore in more detail later, ensures that whenever the product name in your application's data changes, every place you've used product name in your HTML automatically updates to reflect the new value. This happens seamlessly and efficiently, leaving you free from the tedious task of manually manipulating the display. Consider a simple example, a greeting message. If your application's data holds a message property with the value hello world, you can simply write message in your page. If later your application logic changes message to hello Vue user, the displayed text on the page will instantly update without any extra effort on your part to target and modify the HTML element. This declarative approach, where you describe what you want to see rather than how to change it, is a cornerstone of building modern, maintainable web applications with Vue.js. 3.4 Adding dynamic attributes. vbind, while text interpolation is perfect for displaying dynamic text content, sometimes you need to dynamically control the attributes of an HTML element. For example, you might want to set an image's src attribute based on a variable, or disable a button based on a condition, or even apply a CSS class only when certain data is true. This is where Vue's vbind directive comes into play. A directive in Vue is a special attribute that you place on an HTML element, prefixed with v like vbind. These directives tell Vue to do something dynamic with that element. The vbind directive's purpose is to bind an HTML attribute to a piece of your Vue application's data. The general syntax for vbind is vbind, attribute name equals data property. For instance, if you have an image URL property in your data and you want an image element source, src, to be controlled by it, you would write vbind, src equals image URL. Vue would then ensure that the image's source attribute always reflects the current value of your image URL data property. If image URL changes, the displayed image will automatically update. Because vbind is used so frequently, Vue provides a convenient shorthand notation. You can simply use a colon followed by the attribute name. So, src equals image URL means the exact same thing as vbind, src equals image URL. This conciseness helps keep your template code clean and readable. This directive is incredibly versatile. It can be used for any HTML attribute, including href for links, id, class, style, and even custom attributes. This power allows you to control virtually every aspect of your HTML elements dynamically from your application's data. 3.5 Responding to user actions. On. Modern web applications aren't just about displaying data, they're about interaction. Users click buttons, type into input fields, hover over elements, and submit forms. To make your Vue application interactive, you need a way to listen for these user actions and respond to them. This is the job of the Vue directive. The Vue directive is used to attach event listeners to HTML elements. The general syntax is Vue, event name equals method or expression. For example, to react to a button click, you'd use Vue click. The value assigned to Vue click can be a direct expression, like incrementing a number, or, more commonly, the name of a method, a function you have defined in your Vue application to handle that specific event. Let's imagine you have a button that, when clicked, should increase a counter displayed on the screen. You'd define a method in your Vue application that performs the increment. Then, on your button element, you'd add Vue click equals increment count, assuming increment count is the name of your method. Every time the button is clicked, Vue intercepts the click event and executes your increment count method. Because increment count would modify a reactive data property, the displayed counter updates automatically. Similar to vbind, Vue also has a commonly used shorthand, the @ symbol @. So, @click equals increment count is equivalent to Vue click equals increment count. This makes event handling syntax very compact and easy to read. You can use Vue with a wide array of DOM events, such as @input for text fields, @submit for forms, @mouseover, and many more, giving you fine-grained control over how your application reacts to user interaction. 3.6 Two-way data binding for forms, vModel. Collecting user input through forms is a fundamental part of almost every interactive web application. Whether it's typing a name, selecting an option from a drop-down, or checking a box, you need a way to easily get that input into your application's data and, conversely, to display initial values from your data in the form fields. This is where Vue's vModel directive shines, providing what's known as two-way data binding. With vModel, you simply place the directive on an input element, like a text input, text area, checkbox, radio button, or select dropdown, and assign it to a piece of your reactive data. For example, if you have a username data property, you would put vModel equals username on an input field. What happens then is magical, from input to data. As the user types into the input field or selects an option, the username data property in your Vue application automatically updates to reflect the new value. You don't need to write any explicit event listeners to capture the input. From data to input, if your username data property changes programmatically, e.g., you load a user's profile from a server, the input field's value will automatically update to display the new username. This two-way synchronization simplifies form handling tremendously, reducing boilerplate code and making it easy to keep your form inputs and application data perfectly aligned. vModel elegantly handles the common patterns required for various input types, making it the go-to directive for managing user input in Vue.js. 3.7 Conditional rendering. If and vShow. Often, you'll need to display or hide elements in your user interface based on certain conditions. For example, you might want to show a loading message only when data is being fetched, display an error message only if validation fails, or render a specific section only if a user is logged in. Vue provides two main directives for conditional rendering, vif and vShow. The vif directive works by conditionally creating or destroying an element and its contents based on a truthy or falsy value of an expression. If the expression assigned to v, if evaluates to true, the element and any elements nested inside it will be added to the page's structure. If it evaluates to false, the element will be completely removed from the DOM. This means that if if is false, the element doesn't exist in the browser's representation of the page at all. For situations where an element needs to be toggled frequently, vShow might be more efficient. Unlike vif, vShow always renders the element into the DOM, regardless of the condition. Instead of removing it, vShow simply toggles the element's CSS display property. So, if the condition for vShow is false, the element will still be in your HTML structure, but it will be hidden from view. Choosing between vif and vShow depends on your use case. Use if for elements that are unlikely to change frequently, or when the absence of the element from the DOM has performance implications or is part of the application's logic. Use vShow for elements that are toggled on and off very frequently. As it incurs less performance overhead, by just changing a CSS property rather than removing elements from the DOM entirely. Both directives are powerful tools for building dynamic and responsive user interfaces that adapt to your application's state. 3.8 List rendering. V4. Web applications frequently deal with collections of data, such as a list of products, a stream of comments, or a set of search results. Displaying these lists efficiently and dynamically is a common task. Vue's V4 directive is specifically designed to render a list of items based on an array of data. The V4 directive iterates over an array, or an object, or even a range of numbers, and renders a template block for each item. For example, if you have an array of to-dos in your data, and you want to display each to-do as a list item, you would place V4 equals to-do in to-dos on your list item element. Vue would then generate a separate list item for every to-do in your to-dos array, making it incredibly straightforward to display dynamic lists. A crucial concept when using V4 is the key attribute. When Vue renders a list, it needs a way to keep track of each individual element in that list, especially when items are added, removed, or reordered. To do this efficiently, Vue encourages you to provide a unique key for each item in the list. This key should be a stable, unique identifier for that item, like a database ID. Key must be unique to each item in the list. Imagine it like a unique ID tag for each item that Vue uses internally to ensure it can correctly identify and reuse list elements when the data array changes. Without a proper key, Vue might have difficulty updating the list optimally, potentially leading to unexpected behavior or performance issues, especially when items are reordered or filtered. Therefore, always provide a unique key when using V4. The V4 directive not only simplifies the process of displaying lists, but also ensures that updates to your list data are reflected on the screen with optimal performance, creating a smooth experience for your users. 3.9 Bringing it all together. A simple interactive example. Let's imagine creating a very basic interactive application that combines these core concepts. A simple task tracker to help illustrate the synergy of these directives. Suppose you have a header that displays a welcome message and the current number of tasks. Below that, an input field allows you to type in new tasks and a button to add them. Finally, a list displays all the tasks. Each task in the list will have its text and perhaps a small indicator next to it. Here's how our Vue concepts would come into play: welcome message and task count. We'd store the welcome message and the count of tasks in our application's data. We'd then use text interpolation, welcome message, and task count in the header to display these dynamic values. Adding a new task. An input field would be set up with vModel bound to a new task text data property. As you type, new task text updates. A button, probably labeled Add Task, would use vOn, click to trigger a method that takes the value from new task text, adds it to an array of tasks, another item in our data, and then clears the input field. Displaying the task list, our tasks array would be iterated over using V4, with each iteration creating a new list item. Inside each list item, text interpolation would display the task's description. If a task had a status, e.g., pending or completed, we could use vif or vshow to conditionally display a different icon or text next to it. Dynamic styling, conceptual. Perhaps a task could be visually different if it was marked as important. We could use vbind class to dynamically add a special CSS class to a list item if its important status was set to true in our data. This simple example, without a single line of explicit DOM manipulation code, becomes fully interactive and updates automatically thanks to Vue's reactivity system and powerful directives. This declarative approach vastly simplifies the development of dynamic user interfaces, letting you focus on the application's logic rather than the intricate details of browser rendering. In the next chapter, we'll dive deeper into the idea of components, learning how to break down even this simple task tracker into reusable, manageable pieces, setting the stage for building much larger and more complex applications. Chapter 4, Components, the building blocks of a Vue.js application. 4.1, The power of modularity. Why components? In the previous chapter, we explored fundamental Vue.js concepts like reactivity and directives, building a conceptual, simple, interactive application. Even for this seemingly small application, you might have noticed how quickly the different parts of the user interface, the input field, the button, the list of items, started to form distinct units. This observation leads us to one of the most crucial concepts in modern user interface development: components. Think of web applications like intricate machines. Instead of designing and building the entire machine as one monolithic piece, engineers break it down into smaller, manageable, and often reusable parts: gears, levers, buttons, displays. Each part has a specific purpose and can be assembled with other parts to create a functional whole. In web development, these parts are components. A component is a self-contained, reusable piece of code that encapsulates its own structure, HTML template, behavior, JavaScript logic, and styling, CSS. Instead of writing one massive HTML file with interleaved JavaScript and CSS, you define small, focused components, each responsible for a particular piece of your user interface. Why is this modular approach so powerful? Reusability. Once you've built a component, say, a product card that displays an item's image, name, and price, you can reuse it countless times throughout your application. Imagine an e-commerce site. Every product listing on a category page, search results, or even in a related items section can be the same product card component. This saves development time and ensures consistency. Maintainability. When an application grows large, finding and fixing issues in a monolithic codebase becomes a nightmare. With components, if there's a problem with, for example, your user avatar display, you know exactly which component file to open. Changes or bug fixes are isolated and less likely to introduce problems elsewhere. Readability and organization. Breaking down complex UI into smaller components makes your codebase much easier to read and understand. Each component has a clear purpose. This is particularly beneficial when working in teams, as different developers can work on different components concurrently without stepping on each other's toes. Separation of concerns. Components provide a clear separation between an element's appearance, template, and styling, and its behavior, script. This makes it easier to design, develop, and debug specific UI features. Testability. Smaller, self-contained units are much easier to test in isolation. You can verify that a single component functions correctly without having to spin up the entire application. In essence, components are the fundamental building blocks for creating scalable, maintainable, and efficient Vue.js web applications. 4.2 Single File Components, SFCS. The Vue file structure. Vue.js applications often leverage a special file format known as single file components, or SFCs. These files typically have a Vue extension and house all three core aspects of a component: its HTML template, JavaScript logic, and CSS styling, within a single, coherent file. This approach neatly encapsulates everything a component needs to function, making it incredibly intuitive to understand and manage. An SFC is typically divided into three main sections, marked by special tags. Template section. This is where you write the component's HTML structure. It defines what the component will render in the browser. You use standard HTML tags here, along with Vue's directives and text interpolation that we learned about in the previous chapter. Only one root element is allowed directly inside the template section. Script section. This is where you write the component's JavaScript logic. This section defines the component's reactive data, its methods, functions that perform actions like handling clicks or data processing, lifecycle hooks, special functions that run at specific stages of a component's life, like when it's first created, and other JavaScript code necessary for the component's behavior. In modern Vue.js development, particularly with Vue 3, you'll often see the script setup syntax, which simplifies the way you declare reactive data and methods, making the script section even more concise and readable. Style section. This is where you write the component's CSS rules. These styles define the visual appearance of the component. A powerful feature here is the scoped attribute. If you add scope to your style tag, like style scoped, the CSS rules you write within that section will only apply to elements inside that specific component. This prevents your component styles from accidentally affecting other parts of your application. solving a common problem in web development known as CSS global pollution. This single file component structure provides an excellent balance. It keeps all related code for a single component together, promoting modularity, while still maintaining distinct sections for each language, HTML, JavaScript, CSS, ensuring clarity and organizational benefits. 4.3 Using components, registration and usage. Once you've defined a component in its Vue file, you need to tell Vue how to use it in your application. This involves two main steps: registration and usage. Component registration. Before you can use a component, it needs to be registered with your Vue application. This tells Vue about its existence and how to recognize it. There are two main ways to register a component. Global registration. When a component is globally registered, it becomes available for use anywhere within your Vue application without needing to be explicitly imported into every parent component's script section. This approach is convenient for very common, universally used components, like a base button or app header. However, overuse can lead to a larger initial application bundle size if globally registered components are not used everywhere. Global registration usually happens in your main application entry file, e.g., main.js, where you create and mount your Vue application instance. You would simply import the component file and then use a method on the Vue app instance to register it by a chosen name. Local registration. This is the more common and recommended approach for most components. With local registration, a component is explicitly imported and registered within the script section of another component, its parent. This means the component is only available for use within that specific parent component and its template. Local registration helps with code organization, makes your dependencies explicit, and allows build tools to remove unused components, leading to smaller, more efficient application bundles. For example, if your product list component needs to render a product card, you would import product card view into product list view, and then make it available to product list's template through a specific declaration. Component usage. Once a component is registered, either globally or locally, using it in your application's template is as simple as using any other HTML tag. You use its registered name like an HTML element. For example, if you've registered a component named MyButton, you would place MyButton in your template where you want that component to appear. If it's a component that wraps content, like a layout component, you might use an opening and closing tag, like layout component some content layout component. Vue uses a convention called kebab case for component names in templates, e.g. MyButton, even if you define them in Pascal case in your JavaScript, e.g. MyButton. Vue automatically resolves this difference. 4.4 Component scope and self-containment. A key benefit of the component-based architecture is the concept of self-containment and scoping. Each component, particularly when built as a single file component, is designed to largely operate independently. HTML template scope. The template section of a component is self-contained. Any elements defined within one component's template belong to that component. JavaScript script scope. The JavaScript logic within a component's script section, including its data and methods, is private to that component by default. This means that a data property named message in one component will not conflict with a message data property in another component. This isolation prevents accidental interference between different parts of your application and makes your components more reliable and easier to reason about. CSS style scope. As mentioned earlier, the scoped attribute on the style tag ensures that your component's CSS rules only apply to the elements within that specific component. This is achieved by Vue automatically adding unique attributes to your HTML elements and their corresponding CSS rules, preventing style collisions across your application. This means you can confidently write CSS for a specific component without worrying that it will inadvertently change the appearance of components elsewhere on the page. This principle of self-containment means that each component is a miniature, encapsulated application in itself. It has its defined responsibilities, manages its own internal state, and styles itself without affecting or being affected by other components, unless explicitly designed to communicate, which we'll cover in the next chapter. This powerful isolation forms the backbone of building robust, modular, and easily scalable web applications with Vue.js. By embracing components, you transform the complex task of building a web application into an organized, almost assembly line process, where each piece fits perfectly into the larger design, enabling you to build sophisticated user interfaces with confidence and clarity. Chapter 5, Passing Data and Communication, Props, Events, and Slots. 5.1, The Need for Communication, Making Components Talk. In the previous chapter, we established that components are the fundamental building blocks of a Vue.js application. We learned that each component is self-contained, managing its own data, logic, and styling. This isolation is excellent for organization and reusability. However, real-world applications are not just collections of isolated blocks. They are intricate systems where different parts need to interact and share information. A product card needs to display data from the product list. A shopping cart button needs to tell the cart component to add an item, and a layout component needs to receive content to display in its various sections. This necessity leads us to the crucial topic of component communication. How do parent components pass information to their children? How do children notify their parents when something happens within them? And how can a component allow flexible content injection from its parent? Vue.js provides clear, predictable patterns for these common communication scenarios. These patterns primarily flow within the component tree, where components are organized hierarchically, with parent components containing child components, which in turn can contain their own children, and so on. 5.2, Parent-to-Child Communication, Props. The most common form of communication in Vue, and indeed in most component-based frameworks, is passing data from a parent component down to its child components. This is achieved using a mechanism called props. Think of props as custom attributes you can define on a child component, similar to how an HTML element has attributes like src for an image or href for a link. Just as you pass a source URL to an img tag, you can pass data, a piece of text, a number, a Boolean value, or even a more complex JavaScript object or array, as a prop to your custom Vue component. Here's the core idea: defining props in the child. A child component explicitly declares what props it expects to receive from its parent. This is like a component saying, "I'm ready to receive a title and a message from whoever uses me." This declaration helps Vue validate received data and ensures the component knows what to expect. Passing props from the parent. The parent component then passes data to the child by using the prop's name as an attribute on the child component tag in its template. To pass dynamic data, data that comes from the parent's reactive data or a computed property, you use the vbind directive or its shorthand, the colon, to bind a parent's data property to the child's prop. For example, if a parent component has a username data property, it could pass it to a greeting child component like this: greeting name equals username. The greeting component would then have access to the name prop and could display it. The golden rule of props. An important principle when working with props is that data passed down through props should be treated as immutable by the child component. This means the child component should not directly modify a props value. Values flow down the component tree. If a child needs to make a change that affects the props value, it should communicate that desire back up to its parent, which then updates its own data, and that change will flow back down via the prop. This unidirectional data flow makes your application's data highly predictable and easier to debug, as you always know where a particular piece of data originated and how it's flowing through your application. Vue also allows you to add validation to your props. The child component can specify the expected data type for each prop, e.g., string, number, Boolean, object, whether it's required, or even provide a default value if it's not passed by the parent. This helps catch common errors during development. 5.3, Child-to-Parent Communication, Events. While props are perfect for passing data down, child components often need a way to communicate back up to their parents. For example, a save button component within a form might need to tell its parent, "I was clicked, and here's the data from the form." This telling is done through custom events. The process of child-to-parent communication involves two main steps: emitting an event from the child. When something happens inside a child component that its parent might need to know about, a click, an input change, a form submission, the child component emits a custom event. This is like a signal. The child defines the events it can emit, often indicating what kind of information they carry. The child can also include data along with the event, similar to how a native browser click event might carry information about the mouse coordinates. For example, a close button component might emit a closed event, or a user form component might emit a submitted event and include the collected form data along with it. Listening for events in the parent. The parent component, when it uses the child component in its template, can then listen for these custom events. This is done using the familiar Vue directive, or its shorthand, just like listening for native browser events such as at click. The parent assigns a method to the event listener, and when the child emits that specific event, the parent's assigned method is executed, allowing the parent to react to the action and update its own data or perform other necessary logic. So, if your user form component emits a submitted event, the parent might use user form at submitted equals process form data / and Vue would call the process form data method in the parent whenever user form emits its submitted event. The parent's method would automatically receive any data the child included with the emitted event. This props down events up pattern, often summarized as props down, events up, forms a robust and clear communication flow in Vue applications. It ensures that components remain loosely coupled and that data changes are traceable, making your application easier to scale and maintain. 5.4 Content distribution. Slots. Sometimes, you don't want to pass data through a component, but rather inject an entire block of content into a component. This is particularly useful for building highly reusable layout components, wrappers, or components that provide common styling or functionality around arbitrary content. This is where slots come in. Think of a slot as a placeholder in a child component where the parent component can fill in content. It's like a picture frame. The frame, your child component, has a fixed structure, but you, the parent, can put any picture content inside it. Here's how slots work. Defining slots in the child. Inside the child component's template section, you place a slot HTML element at the position where you want the parent's content to be rendered. Providing content from the parent. When a parent component uses this child component, any content placed between its opening and closing tags will be picked up by the child slot and rendered in that position. Types of slots. Default unnamed slots. This is the simplest type. If a child component has a single slot tag without any special attributes, any content the parent puts inside the child's component tags will go into that default slot. For example, MyButtonClickMe/MyButton would render ClickMe inside the MyButton component at the slot position. Named slots. For more complex components that might have multiple areas where content can be injected, e.g., a header, a body, a footer, you can use named slots. In the child, you define slots with a name attribute, like slot name equals header. In the parent, you specify which slot a piece of content is intended for by wrapping it in a template tag with a vslot directive, or its shorthand, followed by the slot's name, such as template header content template. Scoped slots. These are the most advanced and powerful type of slot. Scoped slots allow the child component to pass data back to the parent, but only for the parent to use within the content it provides to that specific slot. This might sound a bit circular, but it's incredibly useful for reusable list components. For instance, a generic list component might iterate over an array of items and provide each item's data to a scoped slot. The parent component then uses this data within the slot to define exactly how each list item should be rendered, combining the child's iteration logic with the parent's rendering logic. Slots empower you to create highly flexible and reusable components that can adapt to different types of content without having to be reconfigured through props for every possibility. 5.5 Putting it together. Effective communication patterns. Understanding props, events, and slots is crucial because they define the fundamental ways components interact in a Vue.js application. Props drive data. They push information down from parent to child, ensuring child components have all the necessary information to render themselves and perform their specific tasks. Always remember the unidirectional flow. Parents pass data, children receive and respond to it, but don't modify the received prop directly. Events signal actions. They allow children to inform their parents when something significant has happened, enabling the parent to react and potentially update its own state, which then cascades down to its children via props. Slots enable flexible content injection. They empower parents to define the inner structure or specific content for certain areas within a child components template, leading to more generic and reusable container or layout components. By mastering these communication patterns, you gain the ability to orchestrate complex interactions between components, building modular, maintainable, and highly responsive user interfaces. While these patterns cover the vast majority of communication needs, for very large applications with global state that needs to be accessed by many components across different parts of the component hierarchy, pattern like global state management libraries, which we'll explore later with Pinia, come into play. But for now, understanding props, events, and slots provides you with the essential toolkit for building connected and interactive Vue.js applications. Chapter 6. Reactivity and Lifecycle. How Vue.js manages your application's state. 6.1. The magic behind the scenes. Vue's reactivity system. In Chapter 3, we glimpsed Vue's remarkable ability to automatically update the user interface when your application's data changes. We called this reactivity. Now, it's time to pull back the curtain and understand this powerful concept more deeply, as it's the very foundation of building dynamic applications with Vue.js. At its core, Vue's reactivity system works by transforming ordinary JavaScript data objects into reactive objects. When you declare data in your component, Vue intervenes behind the scenes. In Vue 3, this is primarily achieved using a modern JavaScript feature called proxies. These proxies allow Vue to intercept operations like reading or writing to your data properties. This means when you access a piece of data, Vue knows you're observing it, and when you modify it, Vue is immediately notified. Once a change is detected in your reactive data, Vue doesn't simply re-render your entire application. Instead, it intelligently identifies precisely which parts of the user interface depend on that specific changed data. It then applies the minimal necessary updates to the DOM, ensuring that your application is not only always in sync with its data, but also performs efficiently, even with frequent changes. This intelligent, fine-grained updating is what gives Vue applications their smooth and responsive feel. Without having to write any manual DOM manipulation code, you can trust that your display will always accurately reflect your application's underlying state. 6.2 Derived Data. Computed Properties. Vue's reactivity opens the door to elegant ways of managing derived data, values that are calculated based on other reactive data. While you could perform these calculations directly in your component's template or as a regular method, Vue offers a more efficient and expressive solution. Computed Properties. A computed property is essentially a data property whose value is automatically recalculated only when its dependencies, the reactive data it relies upon, change. Think of it as an intelligent cache for complex calculations. Here's why computed properties are so beneficial. Efficiency and caching. Unlike a regular method that would run its calculation every single time it's accessed, even if its dependencies haven't changed, a computed property's result is cached. It only reevaluates its calculation when one of the reactive data properties it depends on actually changes. If you access the computed property multiple times within a single render cycle, it will return the cached result immediately, without rerunning the calculation. This makes them significantly more performant for complex or frequently accessed derived values. Readability and expressiveness. Computed properties allow you to declare complex logic that derives values in a clean, declarative way. Instead of scattering calculation logic throughout your template or mixing it with other methods, you define a single, well-named computed property that clearly expresses what value it represents. For instance, if you have a list of products with quantities and prices, a computed property named total order amount would immediately tell you what value it represents, rather than just being a generic calculation method. Automatic dependencies. Vue automatically tracks the reactive data properties a computed property depends on. You don't need to manually specify what should trigger its recalculation. Vue figures that out for you. To illustrate, imagine an application where you enter a first name and a last name. You want to display a full name. Instead of manually concatenating these two every time they're needed, you define a computed property called full name that combines first name and last name. If first name or last name changes, full name automatically updates, and any part of your template displaying full name immediately re-renders. This clear separation of concerns, raw data, and data derived from it is a hallmark of good Vue application design. 6.3 Performing side effects. Watchers. While computed properties are for deriving new data, sometimes you need to perform side effects in response to data changes. A side effect is an action that happens outside the direct calculation of a value. This could include things like making an asynchronous network request, performing complex DOM manipulations, animating an element, or logging a value to the console. For these scenarios, Vue provides watchers. A watcher allows you to watch a specific reactive data property or a computed property and execute a function whenever that property's value changes. This function is your side effect. Watchers are particularly useful for asynchronous operations. When a user types into a search box, you might want to wait a moment to avoid too many requests and then fetch search results from a server. A watcher on the search query data property would be the perfect place for this logic. Complex logic triggered by data change. If a change in one data property requires a series of complex, non-data-related actions, e.g., updating a third-party library, saving preferences to local storage, or triggering an animation sequence, a watcher provides a dedicated place for that logic. Debugging. Sometimes you just want to log the value of a property every time it changes for debugging purposes. It's important to distinguish between watchers and computed properties. If you need to derive a new value from existing reactive data, use a computed property. If you need to perform an action in response to a data change, an action that doesn't directly compute a new value, then a watcher is the appropriate tool. Overusing watchers can sometimes indicate an anti-pattern, leading to less predictable data flow, so it's good practice to choose them judiciously when computed properties aren't suitable. 6.4 The component lifecycle. From birth to passing, every component in a Vue.js application has a lifecycle. This means that from the moment it's created until it's removed from the page, it goes through a series of distinct stages. Vue provides special functions, called lifecycle hooks, that allow you to hook into these stages and execute your own code at specific points in a component's existence. Understanding the component lifecycle is crucial for performing actions at the correct time, whether it's fetching initial data, setting up event listeners, cleaning up resources, or working directly with the DOM. Here are some of the most commonly used lifecycle hooks. On-mounted, the component is ready for action. When it runs, this hook is called after the component has been added to the DOM. At this point, you can be sure that the component's HTML elements are physically present on the page. Common uses. This is an ideal place to perform operations that require the component's DOM elements to exist. Examples include fetching initial data from an API, e.g., loading a list of products when a product list component appears, setting up third-party libraries that need access to the component's DOM, e.g., initializing a chart library, integrating a map component, directly manipulating the DOM if absolutely necessary, though often discouraged in favor of Vue's declarative approach. On-updated, reacting to changes in the display. When it runs, this hook is called after the component has updated its DOM as a result of reactive data changes. Common uses. This hook is typically used when you need to perform actions after the DOM has been re-rendered due to a data update. For example, if you have a chat application and you want to scroll to the bottom of the chat window every time a new message is added, you might do that here, because the onUpdated hook ensures the new message element is already rendered in the DOM. However, be cautious not to update reactive data directly within onUpdated without a clear condition, as it could lead to an infinite update loop. On unmounted, cleaning up after yourself. When it runs, This hook is called just before the component is completely removed from the DOM. Common uses. This is the perfect place to perform any necessary cleanup to prevent memory leaks or unwanted side effects. Examples include removing event listeners that were manually added to the window or document objects, clearing timers or intervals, like setInterval or setTimeout, that began running when the component was mounted, canceling network requests that are still pending, destroying instances of third-party libraries that might still be consuming resources. Other notable hooks include onBeforeMount, called immediately before onMounted, when the component has been configured but its elements haven't yet been rendered to the DOM. onBeforeUpdate, called immediately before onUpdated, when reactive data has changed but the DOM hasn't been re-rendered yet. onBeforeUnmount, called immediately before onUnmounted, when the component is about to be torn down. onErrorCaptured, used for error handling within the component tree, capturing errors emitted from descendant components. By strategically placing your code within these lifecycle hooks, you can ensure that your application performs operations precisely when needed, managing resources effectively and creating a well-behaved and robust user experience. Vue's reactivity system, combined with the power of computed properties, watchers, and lifecycle hooks, provides a comprehensive and elegant way to manage your application's state and behavior. This sophisticated architecture forms the bedrock upon which you can build complex, data-driven web experiences with clarity and efficiency. Chapter 7. Styling your Vue.js apps. From basic CSS to scoped styles. 7.1. The art of presentation. Why styling matters. A well-functioning application needs to look good and be intuitive to use. Styling plays a crucial role in creating an engaging and user-friendly experience. It transforms raw data and functionality into a visually appealing and understandable interface. Just as a sculptor shapes clay, styling with CSS, cascading style sheets, allows us to shape the appearance of our web applications. In traditional web development, managing CSS could become a complex endeavor. Global style sheets could lead to unintended style conflicts, and finding the right rules to modify often felt like navigating a maze. Vue.js, with its component-based architecture, offers several powerful and organized approaches to styling, making it easier to ensure your components look exactly as intended without interfering with each other. 7.2. Standard CSS, global styles and external files. Even with component-based frameworks, standard, globally applied CSS still has its place. You might have a style CSS file that defines base styles for your entire application, such as font families, default text colors, basic reset rules, or general layout properties that apply to many components. This global CSS can be imported into your main application entry file, e.g., main.js, and its rules will apply across the entire application. It's often used for global layout, defining the main grid, overall page width, or common spacing. Typography, setting default font sizes, line heights, and font families. Base element styling, overriding default browser styles for elements like headings, paragraphs, and lists. Utility classes, small, reusable classes that provide specific styling, such as text center for centering text or M4 for a consistent margin. While convenient for broad strokes, relying solely on global CSS can lead to challenges in larger applications. Styles might accidentally overwrite each other, leading to unexpected visual bugs. This is where Vue's component-level styling capabilities become invaluable. 7.3. Component Scoped Styles. The Style Scope tag. One of Vue's most powerful features for managing CSS is the ability to create component-scoped styles. When you define styles within the style section of a single file component, SFC, and add the scoped attribute, Vue automatically ensures that those styles only apply to the elements within that specific component. Here's how it works. When you compile your Vue application, Vue's build process performs a clever transformation. It adds unique, randomly generated attributes to your component's HTML elements, e.g., data v f3 to 4b, and then modifies your CSS rules to target only those elements with the corresponding unique attribute. This means a CSS rule like h1, color, blue, Inside a scoped style tag will only turn the H1 elements within that specific component blue, leaving H1 elements in other components untouched. The benefits of scoped styles are immense. No global pollution. You can write simple, clear CSS selectors, like button, input, or header, without worrying about whether those selectors might unintentionally style elements in other parts of your application. Easier maintenance. When you need to change the styling of a component, you know exactly which file to open, and you can make changes confidently, knowing they won't break the layout of another component. Predictable styling. Each component becomes visually self-contained. Its appearance is determined solely by its own scoped styles and any props it receives, leading to more predictable and robust UI development. While highly recommended for most component-specific styling, it's worth noting that scoped styles are not a bulletproof solution for all CSS challenges. They prevent styles from leaking out of a component, but don't prevent them from being overridden by more specific or globally defined rules from outside the component. Still, for day-to-day component development, style scoped is your best friend. 7.4 Integrating with CSS frameworks. Many developers leverage existing CSS frameworks to accelerate development and ensure design consistency. Frameworks like Bootstrap, Tailwind CSS, or Bulma provide pre-built components and utility classes that can significantly speed up the styling process. Integrating these frameworks into a Vue.js application is generally straightforward. For utility-first frameworks, e.g., Tailwind CSS. These frameworks typically provide a vast array of utility classes, like TextXL, BGBlue 500, P4, that you apply directly to your HTML elements within your component's template. You would generally install the framework via npm and then configure your build process, usually handled by Vite, to process its CSS. Since Tailwind classes are applied directly in the HTML, they work seamlessly with Vue components without needing special directives. For component libraries, e.g., Bootstrap Element UI, these frameworks often come with pre-designed components, buttons, navbars, cards that you can use. You might install the framework CSS globally, as discussed in 7.2, or import specific components that Vue wrappers might provide. Vue also has dedicated UI component libraries built specifically for it, such as Vuetify or Quasar, which offer pre-built Vue components that implement the framework's design system and integrate deeply with Vue's reactivity. Using a CSS framework can be a great way to achieve a professional look with minimal effort, providing a solid design foundation that you can then customize with your scoped component styles. 7.5 Dynamic styling with vbind, class and vbind, style. In addition to static styling, Vue provides powerful capabilities for applying styles dynamically based on your application's data. This is achieved using the vbind directive, or its shorthand, with the class and style attributes. Binding HTML classes, class. You can bind the class attribute to a JavaScript object or array in your Vue components data. This allows you to dynamically add or remove CSS classes based on conditions. Object syntax. You can define an object where keys are class names and values are Boolean expressions. If an expression evaluates to true, the class is applied. Otherwise, it's removed. For example, class equals active item, is active, disabled button. Is disabled would apply active item if is active is true, and disabled button if is disabled is true. Array syntax. You can also provide an array of class names. These can be strings or more objects like the one above. For example, class equals base style, highlight is highlight. This is particularly useful when you have a set of base classes that are always present, plus additional classes that are conditional. Binding inline styles, style. Similarly, you can bind the style attribute to a JavaScript object, where property names are CSS properties, in camel case, e.g., background color, and values are their corresponding style values. For example, style equals color, text color, font size plus px, would dynamically set the color and font size of an element based on data properties text color and font size. This allows for extremely fine-grained, data-driven styling. These dynamic binding capabilities are invaluable for creating highly interactive user interfaces where visual feedback is crucial. such as highlighting active navigation items, displaying error states, or adjusting element sizes based on viewport dimensions. By combining global stylesheets for broad definitions, scoped styles for component encapsulation, the utility of CSS frameworks, and the flexibility of dynamic class and style binding, Vue.js provides a robust and organized ecosystem for managing all your application's styling needs, ensuring both visual consistency and development efficiency. Chapter 8, Navigating Your Application, Introduction to Vue Router. 8.1, The Illusion of Multiple Pages. What is client-side routing? When you browse the internet, you're accustomed to clicking a link and having a new page load, resulting in a momentary blank screen and a full page refresh. This is characteristic of what's known as a traditional multi-page application, MPA. While effective, this approach can feel slow and clunky, especially for highly interactive web experiences. Modern web applications, particularly those built with frameworks like Vue.js, often strive to provide a smoother, more fluid user experience, akin to a desktop application. This is achieved through the concept of single-page applications, SPAs. In SPA, the user's browser initially loads a single HTML file. After this initial load, all subsequent interactions and navigations happen dynamically within that single page. When you click a link or navigate between different views within an SPA, the browser's URL might change, but the entire page doesn't reload. Instead, only the necessary parts of the content are swapped out, often with seamless transitions. This magical ability to change views without a full page refresh is powered by client-side routing. Instead of sending requests to a server for entirely new HTML documents, a client-side router intercepts browser URL changes and programmatically swaps out Vue components in the browser, manipulating the browser's history API to keep the URL in sync. This provides the illusion of navigating between different pages, while the user remains on the same HTML document. The benefits of client-side routing are significant. Faster transitions, a smoother user experience, less server load, as the server only needs to send data, not full HTML pages, and the ability to build rich, application-like interfaces directly in the browser. 8.2, Introducing Vue Router, the official routing library. To manage this client-side routing in a Vue.js application, developers almost universally turn to Vue Router. It's the official routing library maintained by the Vue.js team, built specifically to integrate seamlessly with Vue applications. Its purpose is to map URL paths to specific Vue components, allowing your application to show different content based on the browser's current address. Vue Router provides a dedicated set of tools and components to handle routing effectively. To use it, you would typically install it as a separate package using your Node.js package manager, like npm or yarn, as it's not part of the core Vue library. Setting up Vue Router involves defining a collection of routes. Each route is an object that specifies a URL path and the Vue component that should be displayed when that path is active. These route definitions are often centralized in a dedicated file, typically named router/index.js, where they are then used to create a router instance. This router instance is then integrated into your main Vue application, making it aware of all the defined routes. Once integrated, Vue Router introduces a special component, usually named RouterView. This component acts as a placeholder. Whenever your application navigates to a new route, Vue Router intelligently determines which component should be active for that route and renders it directly into the router view's position within your application's layout. You can think of router view as the dynamic display area where your routed components will appear. 8.3, Defining simple routes, path and component mapping. The most fundamental aspect of Vue Router is the ability to define a direct mapping between a URL path and a Vue component. This tells Vue Router, when the browser's URL is about, display the about component. A route definition typically involves at least two key pieces of information. Path, a string representing the URL path. This could be something simple like home, products, or contact. Component, the Vue component that should be rendered when the path matches the current browser URL. So, in your router configuration file, you would define an array of route objects. For instance, One route might be defined as an object where the path is about, and the component is your About page component. Another route might have a path of services and point to a services page component. When a user navigates to About, Vue Router will automatically render the contents of your About page component into the Router view placeholder. This straightforward mapping allows for clear organization of your application's main sections, ensuring that each distinct URL corresponds to a specific, self-contained Vue component. 8.4 Dynamic routes. Handling variable paths. Many applications need routes that aren't fixed but contain variable parts. Consider a social media platform. You wouldn't create a separate route for every single user's profile, users John, users Mary, users Susan. Instead, you'd want a single pattern that captures all user profiles, like users followed by a user's ID or username. This is where dynamic routes come into play. Vue Router allows you to define dynamic segments within your route paths. You mark a segment as dynamic by prefixing it with a colon. For example, a dynamic route for user profiles would be defined as /users/d. Here, id is a placeholder that will match any value in that position of the URL. When such a dynamic route becomes active, the component associated with that route will receive the value of the dynamic segment as a parameter. This parameter can then be accessed within your component's JavaScript logic. For example, if the URL is users123, the component would receive 123 as the value for the id parameter. This allows you to fetch and display the data for the specific user, or product, or article, etc., based on the ID provided in the URL. Dynamic routes are essential for building flexible and scalable applications where content is driven by specific identifiers within the URL. 8.5 Nested routes. Building hierarchical UIs. Applications often have complex internal structures where one view contains subviews. For example, a dashboard might have a settings section, which then contains settings profile, settings account, and settings notifications. Instead of defining these as completely separate, top-level routes, Vue Router supports nested routes. Nested routes allow you to reflect the hierarchical structure of your application's UI directly in your routing configuration. When a parent component manages a particular area of the UI, its child routes can render their content within that parent component. To set up nested routes, you define a children array directly within a parent routes definition. Each object in this children array is itself a route definition, with its own path and component. The path for a nested route is relative to its parent's path. So, if the parent's path is settings, a child route with path, profile, would resolve to settings profile. The key to rendering nested routes is that the parent component must also include a router view component within its own template. This inner router view acts as a placeholder specifically for the child routes defined under that parent. When settings profile is active, the settings component would be rendered into the main router view of your application, and then the profile component would be rendered into the router view inside the settings component. This composition allows for modular and intuitive UI layouts where different parts of a page can be managed by different route views. 8.6 Navigating your application. Router link and programmatic navigation. Once your routes are defined, users need a way to navigate between them. Vue Router provides two primary methods for this: declarative navigation with router link. For most navigation within your templates, you'll use the special router link component provided by Vue Router. This component works much like a standard HTML, a anchor tag, but it's intelligent. Instead of a href attribute, router link uses a to-prop, which specifies the target route. When a user clicks a router link, Vue Router intercepts the click and performs the client-side navigation without causing a full page refresh. Router link automatically handles managing the browser history and even applies a special CSS class, like router link active, to the active link, allowing you to easily style the currently selected navigation item. You use it by simply placing router link to /about us router link in your template. Programmatic navigation. While router link is excellent for direct UI navigation, there are many situations where you need to navigate programmatically, meaning your navigation logic is triggered within JavaScript. This commonly happens after a form submission is successful. an asynchronous API call completes. A user performs a specific action that changes the application's state and warrants a view change. You need to redirect a user based on certain conditions, e.g., if they are not authenticated. To perform programmatic navigation, you can access the router instance directly within your component's JavaScript. The most common method is router push, /path/to/route, which simulates a click on a router link and adds a new entry to the browser's history stack. You can also pass an object to push for more complex navigation, including dynamic parameters or query strings. Other methods like router replace, navigating without adding to history, and router go, navigating forward or backward end steps in history, are also available for finer control. Being able to choose between declarative router link and programmatic navigation gives you versatile control over how users move through your application, ensuring a seamless and efficient experience. 8.7 Navigation Guards, controlling access. For more advanced scenarios, Vue Router offers navigation guards. These are essentially functions that execute at different stages of the navigation process, e.g., before a route is entered, as it's entered, or as it's left. They act as a form of middleware, allowing you to perform checks or logic that might modify or cancel navigation. Common uses for navigation guards include authentication, redirecting unauthenticated users away from private routes; authorization, checking if a user has the necessary permissions to access a particular route; data fetching, prefetching data needed by a component before it renders, ensuring content is available immediately upon viewing; confirmation prompts, prompting a user before they leave a page with unsaved form data. While implementing navigation guards can be more complex, understanding their existence is important. They provide a powerful way to add security, data loading, and complex navigation logic directly into your routing configuration, making your application more robust and user-friendly. Vue Router provides a comprehensive and flexible solution for managing client-side navigation in your applications. By mastering its core concepts, you unlock the ability to build sophisticated single-page applications that feel responsive, maintainable, and delightful for your users. Chapter 9, Managing Application State, an Introduction to Pinia. 9.1 The Challenge of Growing Applications, State Management. As your Vue.js application grows beyond simple components and a few interacting elements, you'll inevitably encounter a common challenge: managing application state. State refers to all the data that your application needs to function at any given moment. This could include the currently logged-in user, items in a shopping cart, preferences, fetched data from an API, or the visibility of a modal window. In smaller applications, you might rely on props to pass data down from parent to child components and custom events to send information back up. This pattern, as discussed in Chapter 5, works beautifully for communication between directly related components. However, this approach can quickly become unwieldy in larger applications. Prop drilling. Imagine you have a piece of data that's needed by a component several levels deep in your component tree. You would have to pass that prop down through every intermediate component, even if those components don't directly use the data themselves. This is known as prop drilling, and it makes your code harder to read, maintain, and refactor. Sibling communication. What if two components, component A and component B, need to share information, but they don't have a direct parent-child relationship, e.g., they are siblings or cousins in the component tree? Communicating between them would often involve passing data up to a common ancestor, and then down to the other sibling, leading to convoluted event chains. Global data maintenance. Some data, like user authentication status or a global user preferences setting, logically belongs to the entire application. Maintaining such global data across many disparate components without a centralized system can lead to inconsistencies and bugs. Each component might end up fetching or managing its own copy of the same data, leading to a tangled mess. These challenges highlight the need for a more robust and centralized solution for managing global or widely distributed application state. This is where dedicated state management libraries come in. 9.2 Introducing Pinia, Vue's recommended state management library. For Vue.js applications, the recommended and official state management library is Pinia. It's designed to be lightweight, intuitive, and offers excellent developer experience, greatly simplifying the way you manage shared data across your application. Pinia is often described as a stores system, where each store represents a specific module or feature of your application's state. Pinia shares fundamental concepts with its predecessor, Vuex, but introduces a simpler and more modern API, leveraging Vue 3's composition API naturally. It's built with type safety in mind, especially useful if you're using TypeScript, but beneficial even without. Offers great debugging support via Vue Dev tools, and is designed to be highly scalable. The core idea behind Pinia is that you extract pieces of your application's shared state and logical operations that modify that state into separate, self-contained units called stores. These stores then provide a centralized location for accessing and modifying that state from any component within your application, eliminating the need for prop drilling and complex cross-component communication. 9.3 The core concepts of Pinia: stores, state, getters, and actions. Pinia organizes your application's global state into stores. Each store is essentially a mini application that manages a specific segment of your overall state. A store is defined by a few key elements. State: this is where you declare the actual data that the store will hold. Much like a component's data option, the state in a Pinia store is reactive. Any changes to this state will automatically trigger updates in any components that are using it. For example, a user store might have a state containing username and is authenticated, while a cart store might have a state containing items, an array of products, and total price. Getters in Pinia are analogous to computed properties in Vue components. They allow you to define derived state based on the store's state. Getters are essentially functions that perform calculations or transformations on the state and return a new value. Like computed properties, getters are cached, meaning they only reevaluate their result when their underlying state dependencies change. This makes them efficient for retrieving filtered lists, calculated totals, or any piece of data that needs to be derived from the raw state. For instance, a cart store might have a getters called total items in cart that sums up the quantity of all items in the items array. Actions. Actions are the recommended way to modify the store's state. While you can directly modify state in Pinia, actions provide a structured and centralized place for all your state-altering logic. Actions are especially powerful because they can contain asynchronous operations, like making API calls to fetch or save data. They typically take care of updating the state after an asynchronous operation concludes. For example, a user store might have an action called login that takes username and password, makes an API call to authenticate the user, and then, if successful, updates the isAuthenticated and username properties in the store's state. Components will then call these actions to trigger state changes. 9.4 Integrating Pinia into your application. Integrating Pinia into your Vue.js application is a straightforward process. Installation. First, you install Pinia using your package manager, e.g., npm install Pinia. Creating the Pinia instance. In your main application entry file, e.g., main.js, you create the central Pinia instance, similar to how you create the Vue Router instance. This instance is then provided to your main Vue application, making Pinia available globally. Defining stores. You typically create separate files for each of your Pinia stores, organizing them by feature or module. For example, you might have stores/user.js, stores/cart.js, etc. Each file defines a store using Pinia's specific functions, exporting it for use in components. Using stores in components. To access a store's state, getters, or actions from within a Vue component, you use the store using a special Pinia function. This makes the store's properties and methods available within your component's template and script sections. You can then display state values, use getters as if they were computed properties, and call actions as if they were methods. Here's a conceptual flow. A user clicks a button in Product Hard Component. Product Hard Component calls an action from the cart store, e.g., cart store add item. The add item action updates the items in the cart store's state. The total items in cart getter in the cart store automatically recalculates its value. Any component that displays total items in cart, e.g., header component showing a cart badge, or iterates over items, e.g., cart page component, immediately updates its display, thanks to Vue's reactivity system. 9.5. The benefits of centralized state management with Pinia. By adopting Pinia for state management, your application gains significant advantages. Centralized source of truth. All shared data resides in predictable locations within your stores, making it easy to understand where a piece of data comes from and how it's being managed. Predictable state changes. By channeling all state modifications through actions, you ensure that changes happen in a controlled and traceable manner, reducing the risk of unexpected bugs. Improved maintainability. Related data and the logic to manage it are grouped together in dedicated stores, making your code base more modular and easier to understand, especially as your application scales. Enhanced debugging. Pinia integrates beautifully with Vue dev tools, providing a live, interactive view of your application's state, showing you how actions are dispatched and how state changes over time. This makes debugging complex state flows much simpler. Scalability. As your application grows, you can easily add new stores for new features without impacting existing ones, allowing your state management solution to scale alongside your application. Pinia is an essential tool for building complex, data-driven Vue.js applications. It frees you from the complexities of direct component-to-component communication for global data, allowing you to focus on building features while ensuring that your application's state remains robust, predictable, and manageable. Chapter 10, Connecting to the World, Working with APIs. 10.1, The web is connected. What are APIs? So far, we've focused on building the user interface of our Vue.js applications, managing their internal data, and allowing components to communicate. But modern web applications rarely exist in a vacuum. They need to interact with the outside world, often by fetching data from external services or sending data to be stored or processed elsewhere. This interaction happens through APIs, which stands for Application Programming Interfaces. Think of an API as a waiter in a restaurant. You, the customer, your Vue.js application, don't go into the kitchen, the server, or database yourself to get your food, the data. Instead, you give your order to the waiter, the API, who takes it to the kitchen, retrieves your food, and brings it back to you. The API provides a standardized way for different software systems to communicate with each other, defining the methods and data formats that applications can use to request and exchange information. In the context of front-end development, we primarily interact with web APIs, specifically REST-TFL APIs, representational state transfer. These APIs typically use standard HTTP requests, like GET, POST, PUT, DELETE, to perform operations on resources, like users, products, or orders, identified by URLs. For example, a GET request to /API/products might retrieve a list of all products, while a POST request to /API/orders might send new order details to the server. Most commonly, data transferred via these APIs is formatted in JSON, JavaScript object notation, a lightweight and human-readable data interchange format that JavaScript understands natively. Connecting your front-end application to a back-end API is crucial for building dynamic applications that can fetch and display dynamic data, e.g., loading a list of movies, weather forecasts, or news articles. Submit user input, e.g., creating a new user account, saving a blog post, or placing an order. Update existing data, e.g., changing a user's profile information. Delete data, e.g., removing an item from a list. 10.2 Asynchronous operations, waiting for data. When your Vue.js application makes a request to an external API, it's an asynchronous operation. This means your application doesn't stop and wait for the response to come back before continuing its execution. Instead, it sends the request and immediately moves on to other tasks. When the API eventually responds, which could take milliseconds or several seconds depending on network conditions and server load, your application receives the data and can then process it. This asynchronous nature is critical because if your application were to block and wait for every network request, the user interface would freeze, leading to a terrible user experience. JavaScript handles asynchronous operations using various mechanisms, most notably promises and the async await syntax. Promises. A promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. It allows you to chain operations together. Do this, then when that's done, do this other thing, and if anything goes wrong, handle it this way. Async await. This is modern JavaScript syntax that allows you to write asynchronous code that looks and behaves more like synchronous code, making it easier to read and reason about. You mark a function as async to indicate it will perform asynchronous operations, and then use await inside that function to wait for a promise to resolve before continuing. When working with APIs, you'll constantly be dealing with these asynchronous patterns to ensure your application remains responsive while waiting for data. 10.3 Fetching data. The native Fetch API. Modern web browsers come with a built-in function called the Fetch API. This is the native JavaScript way to make network requests, and it's a powerful tool for interacting with APIs directly without needing to install any third-party libraries. The Fetch API returns a promise, which makes it well-suited for use with async await. A typical data fetching operation involves calling fetch with the URL of the API endpoint you want to access, awaiting the response. The initial response object contains metadata about the response, like status codes, but not the actual data payload itself. Calling a method on the response object, often response.json, to parse the response body as JSON. This also returns a promise, so you'll await it again to get the actual data. Handling potential errors, such as network issues or server errors. Using Fetch API is great because it means one less dependency for your project. For simple GET requests, it's often all you need. However, for more complex scenarios, like automatically adding headers, retraying requests, or handling request cancellation, a dedicated HTTP client can simplify your code even further. 10.4 A more feature-rich alternative, Axios. While the native Fetch API is powerful, many developers prefer to use a third-party library called Axios for making HTTP requests. Axios is a popular promise-based HTTP client that can run in both browsers and Node.js environments. Axios offers several advantages over the native Fetch API, making it a favorite for complex applications. Simpler API. Axios often requires slightly less boilerplate code to perform common tasks, especially for POST, PUT, delete requests where you need to send data in the request body. Automatic JSON transformation. Axios automatically transforms JSON request data when sending and response data when receiving, so you don't explicitly need to call response.json. Interceptors. Axios allows you to define interceptors, which are functions that can modify requests before they are sent or responses before they are handled. This is incredibly useful for common tasks like adding authentication tokens to every outgoing request or logging errors centrally. Request cancellation. Axios provides a straightforward way to cancel requests, which is important for preventing race conditions or unnecessary network traffic, especially if users navigate quickly between pages. Better error handling. Axios generally provides more consistent error handling across different browser environments than Fetch. To use Axios, you first install it using your package manager, e.g., npm install Axios. Then you can import it into your Vue component or Pinia store and use its methods like Axios get, Axios post to interact with your API. 10.5 Displaying loading states and handling errors. When making API requests, it's crucial to consider the user experience during the wait time and manage potential errors gracefully. Your application should always provide feedback to the user and handle unexpected situations. Displaying loading states. Since API requests are asynchronous, there will be a brief period between sending the request and receiving the response. During this time, your application should indicate that something is happening. This can be achieved by loading spinners indicators, displaying a visual animation to show that data is being fetched. You might use a Boolean flag in your Vue components data, e.g., is loading equals true, and bind it to a VIF directive on your loading spinner. Skeleton screens, showing a simplified wireframe version of the content that's about to load, providing a visual placeholder. Disabling UI elements, temporarily disabling buttons or input fields to prevent users from making further changes while a request is in progress. You would typically set the isLoading flag to true just before making the API request and set it back to false in both the success and error callbacks of your request. Handling errors. Network requests are prone to errors. The server might be down, the internet connection might be lost, or the API might return an error due to invalid data. Your application should never crash silently. Best practices for error handling include catching errors, using catch with promises or try ... catch blocks with a sync await to gracefully intercept errors. Displaying user-friendly messages. Instead of cryptic error codes, show a clear message to the user, e.g., failed to load products. Please try again later. You might have an error message data property that you display conditionally. Retrying requests. For transient network errors, you might offer the user an option to retry the request. Logging errors. For debugging purposes, you might log the full error details to the browser console or send them to an error tracking service. By incorporating loading states and robust error handling, you create a more reliable and user-friendly application, even when dealing with the unpredictable nature of network communication. Connecting your Vue.js application to external APIs transforms it from a static interface into a dynamic, data-driven experience. Whether you choose the native Fetch API or the feature-rich Axios library, understanding how to make asynchronous requests, manage loading states, and handle errors is fundamental to building modern, real-world web applications. These skills allow your application to truly connect to the world of data and services beyond its own confines. Chapter 11, User Input and Forms, Handling Data Collection. 11.1, The Bridge to Interaction. Why forms matter. Web applications are rarely static displays of information. More often than not, they are about interaction, and a core part of that interaction involves user input. Whether it's creating a new account, placing an order, searching for content, or leaving a comment, forms are the primary way users provide information to your application. Building robust and user-friendly forms is crucial for both functionality and user experience. Forms must not only collect the necessary data, but also provide clear feedback to the user, guiding them through the process and helping them correct errors. Managing the state of various input fields, ensuring the data is valid, and then gracefully submitting that data to a server can become quite complex. Vue.js offers powerful directives and patterns to simplify this process, making form handling intuitive and efficient. 11.2 vModel, the two-way street for inputs. In Chapter 3, we briefly introduced vModel as a way to create two-way data binding for input elements. Now, let's explore it in more detail, as it's the cornerstone of handling user input in Vue.js. At its essence, vModel is a sophisticated shortcut. Behind the scenes, it intelligently combines two simpler directives: vbind to set the input's value attribute to a piece of your Vue components data, and von, input, or von, change for some input types, to listen for user input events and update that same data property. This creates a seamless flow where any change in the input field instantly updates your data, and any change in your data instantly updates the input field's display. This synchronization makes form handling incredibly straightforward compared to manually managing these interactions with separate event listeners and value bindings. vModel adapts its behavior slightly depending on the type of input element it's applied to. Text inputs, input type equals text, text area. For single-line text fields and multi-line text areas, vModel binds directly to a string data property. As the user types, the data property updates character by character. Number inputs, input type equals number. While number input fields accept numeric input, they technically still return a string. If you want Vue to automatically convert the input to a JavaScript number type, you can use the number modifier with vModel, e.g., vModel number equals a checkboxes, input type equals checkbox. Single checkbox. When used with a single checkbox, vModel binds to a Boolean data property. When the box is checked, the property becomes true; unchecked, it becomes false. Multiple checkboxes. If you have multiple checkboxes that should represent a group of selected options, vModel can bind to an array. Each checkbox in the group should have a value attribute. When a checkbox is checked, its value is added to the array. When unchecked, it's removed. Radio buttons, input type equals radio. For a group of radio buttons where only one can be selected, vModel binds to a single data property. The value assigned to that property will be the value attribute of the currently selected radio button. Select dropdowns, select. Single selection. For a standard dropdown where only one option can be selected, vModel binds to a single data property. The value of this property will be the value attribute of the chosen option. Multiple selection. If the select element has the multiple attribute, vModel binds to an array. All value attributes of the selected options will be collected into this array. vModel also offers other useful modifiers, such as lazy, to update the data only when the input element loses focus instead of on every keystroke, and trim, to automatically remove leading and trailing whitespace from string inputs. These modifiers provide fine-tuned control over how input data is processed before it updates your reactive state. 11.3 Handling form submission. The journey of collected data culminates in form submission. Once a user has filled out the necessary fields, they typically click a Submit button. It's crucial to correctly intercept this action and prevent the browser's default submission behavior, which would cause a full page refresh, something we generally want to avoid in SPAs. When working with a form element in Vue, you'll primarily use the v-on submit directive or its shorthand at submit. To prevent the browser's default page reload, you add the prevent modifier to the submit event, at submit prevent. This tells Vue to execute your custom event handler method while stopping the browser from taking its default action. Inside the method triggered by at submit prevent, you'll typically perform the following steps. Validation. Before sending any data to a server, you should validate the collected input to ensure it meets your requirements, discussed in the next section. Data processing. If the validation passes, you prepare the form data, perhaps by packaging it into a JavaScript object for transmission. API call. You then send this data to your backend server using a networking library like Axios or the native Fetch API, as discussed in Chapter 10. This will typically be an asynchronous operation. Feedback and redirection. Based on the server's response, you provide feedback to the user, e.g., submission successful or error, invalid email address, and potentially redirect them to another page using Vue Router, Chapter 8, or change the application state. By taking control of the form submission, you gain precise management over the data flow and user experience. 11.4 Client-side form validation. Ensuring good data. Validation is the process of ensuring that the data a user provides meets certain criteria before being processed or sent to a server. It's a critical part of form handling for two main reasons. User experience. Providing immediate feedback to the user about what went wrong is far better than them submitting a form only to discover an error after a server round trip. Client-side validation catches common mistakes instantly, guiding the user to correct their input without frustration. Data integrity. While client-side validation is primarily for user experience, it also provides an initial filter for bad or incomplete data, saving unnecessary requests to your backend server. It's important to remember that client-side validation is never a substitute for server-side validation. Malicious users can bypass client-side checks, so your backend should always revalidate all incoming data to ensure security and data integrity. Common client-side validation rules you might implement include required fields, ensuring a field is not left empty. Minimum/maximum length, checking if a text input meets specific character count requirements. Format pattern matching, validating against a specific format, such as an email address, e.g., checking for an @ symbol and a domain or a phone number. Regular expressions are often used for this. Numerical ranges, ensuring a number falls within a specific range, e.g., age between 18 and 99. Confirmation, matching two fields like a password and confirm password. To implement validation in your Vue component, you typically define reactive data properties that hold the error messages for each field, e.g., email error message, password error message. When the form is submitted, or even as the user types, often called on-the-fly validation, you run checks against your input data. If a validation rule is violated, you update the corresponding error message property. 11.5 Displaying validation errors. User feedback. The validation logic itself isn't enough. You must effectively communicate errors back to the user. Clear and immediate feedback is essential for a good user experience. Here's how you typically display validation errors and provide visual cues. Conditional error messages. Using the VIF directive, you can conditionally display the error message text below or next to the offending input field. For example, pvif equals email error message, p. The email error message data property would be set to an empty string or null if validation passes, and a relevant error message string if it fails. Highlighting invalid fields. To make errors more visually prominent, you can dynamically apply CSS classes to input fields that are invalid. Using vbind, class, or its class shorthand, you can add a class like error field, which might have a red border, to an input based on its error state. For instance, input class equals error field, email error message, timing of validation. Consider when to trigger validation. On blur change, you can validate a specific field as soon as the user finishes typing or moves away from it, the blur event, providing immediate feedback for that field. On submission, you perform a comprehensive validation of all fields when the user clicks the Submit button. This ensures that even if individual fields were not validated on the fly, the entire form is checked before submission. Often, you'll combine both strategies. Validate on blur for individual fields, and then a full check on submission. By following these principles and leveraging Vue's reactivity and directives, you can build powerful and user-friendly forms that not only collect data efficiently, but also guide the user with clear feedback every step of the way. This lays the groundwork for creating rich interactive experiences that truly engage your application's users. Chapter 12. Ensuring quality, testing your Vue.js applications. 12.1 The value of confidence. Why testing is crucial. Imagine building a complex machine with many moving parts. How would you ensure it functions correctly and reliably every single time? You test each part individually, then test how they interact, and finally, test the whole machine under various conditions. Software development, especially for interactive web applications, is no different. Testing is the process of verifying that your code behaves as expected, that it meets its requirements, and that it doesn't introduce unintended side effects or errors. While writing code that just works on your machine might feel sufficient in the short term, effective testing provides profound benefits for any serious application. Bug prevention and early detection. Tests act as a safety net, catching bugs before they reach your users. They prevent regressions, new bugs from appearing in old, previously working code. Confidence in refactoring, code bases evolve. When you need to change or improve existing code, refactor, a comprehensive test suite gives you the confidence that your changes haven't broken anything. Documentation and understanding. Tests serve as executable documentation. By looking at a test, you can quickly understand what a piece of code is supposed to do and how it should behave in different scenarios. Collaboration. In team environments, tests ensure that everyone adheres to expected behaviors. When a new developer joins, tests help them understand the system and ensure their contributions don't break existing functionality. Maintainability. Over time, well-tested code is easier to maintain and extend because its intended behavior is clearly defined and protected. While manual testing, clicking around your application, has its place, it's time-consuming, prone to human error, and doesn't scale. This chapter focuses on automated testing, where code is written to verify other code, providing rapid, repeatable, and reliable checks. 12.2 Types of testing. A layered approach. Automated testing generally involves different layers or types of tests, each serving a specific purpose and operating at a different granularity. Unit tests. Focus. the smallest testable parts of an application, typically individual functions, methods, or small, isolated pieces of logic. Goal: to verify that these isolated units behave correctly given specific inputs. Characteristics: fast to run, easy to write, and highly precise in pinpointing where a bug originates. They don't typically interact with the DOM or full components. Example: testing a function that calculates a shopping cart total, ensuring it returns the correct sum for various product arrays. Component tests, integration tests. Focus: testing individual Vue components in isolation, including their templates, scripts, and interactions with props, events, and slots. Goal: to verify that a component renders correctly, responds to user interactions, clicks, input, and communicates effectively with its parent or child components. They ensure the component's internal logic and template rendering work together as expected. Characteristics: these tests leverage the component's API, props, events, and simulate user interaction. Example: testing a login form component to ensure it displays error messages when fields are empty, or that it emits a login event with correct credentials when the submit button is clicked. End-to-end E2E tests. Focus: testing the application as a whole from the user's perspective, mimicking real user flows. Goal: to verify that entire user journeys involving multiple components, pages, and potentially backend interactions function correctly. They test the application through its UI, often in a real browser. Characteristics: slower to run, more complex to write, but provide the highest confidence that the entire system works collaboratively. They test the happy path a user would take. Example: testing a checkout flow. Navigate to a product page, add item to cart, proceed to checkout, fill billing details, submit order, and verify a confirmation message. While all layers are valuable, for front-end applications like Vue.js apps, component tests often provide the best balance of confidence and development speed, bridging the gap between isolated unit tests and slow E2E tests. 12.3 Test runners and testing utilities. To write and execute automated tests for your Vue.js applications, you'll use a combination of tools. Test runner: this is the environment that executes your tests and provides reporting. For modern Vue 3 applications, Vitest is the recommended choice. Vitest is a fast, next-generation test framework powered by Vite, the build tool we discussed in Chapter 2. It's designed for speed and integrates seamlessly with your Vue project, often providing instantaneous feedback as you write tests. Testing utilities, e.g., Vue test utils. While a test runner executes your tests, you also need libraries that provide Vue-specific helpers for writing component tests. Vue test utils is the official testing utility library for Vue.js. It simplifies the process of mounting, rendering your Vue components in an isolated testing environment, interacting with them, simulating clicks, input, and asserting their rendered output or emitted events. It abstracts away the complexities of interacting with Vue's reactivity system during tests. When you scaffold a new Vue project with Vite, you often have the option to include basic testing setup, which will likely pre-configure Vitest and Vue test utils for you, giving you a ready-to-go testing environment. 12.4 Basic unit testing, component logic. Even when focusing on component tests, it's beneficial to isolate and unit test pure JavaScript logic that might exist outside of the direct component's template or rendering. This could be a utility function, a data validation function, or a complex calculation that your component uses. For example, if you have a simple function that calculates the tax on an item, you would create a separate test file for it. Your test would import the function, call it with various inputs, and then use assertion methods provided by Vitest/jest to check if the function returns the expected output. Example of a utility function: conceptual. Function calculate tax, price tax rate, return price tax rate. Example of a unit test file: conceptual. Import describe it, expect from Vitest, assuming calculate tax is imported or accessible. Describe calculate tax equals. It should calculate tax correctly for a given price and rate equals. Assert 1. Basic tax calculation. Const result 1 equals calculate tax 100 0.10 10% tax. Expect result 1 to be 10 assert 2. 0 tax rate. Const result 2 calculate tax 0, expect result 2 to be 0. Assert 3, higher tax rate. Const result 3 equals calculate tax 200, 0.25. 25% tax. Expect result 3 to be 50. You can add more tests for edge cases, like negative inputs, etc. This demonstrates testing pure functionality in isolation, ensuring the underlying logic is sound before it's integrated into a component. 12.5 Component testing, rendering and interaction. Component testing is where the bulk of your Vue application testing will likely occur. Here, you focus on how your component renders its template, how it responds to props, how it emits events, and how it reacts to user interactions. Using Vue test utils, you can mount a component, which means rendering it into a virtual DOM environment for testing purposes. Once mounted, you can check initial render. Assert that the component's initial output, e.g., text content, number of elements, existence of certain classes, matches expectations. Pass props. Simulate passing props to the component and verify that the component updates its display accordingly. Simulate user interaction. Use testing utilities to simulate user actions like clicking a button, typing into an input field, or selecting an option from a dropdown. Assert on output events. After interaction, assert that the displayed content has changed as expected, or that the component has emitted the correct events with the correct data. Example of a simple Vue component, conceptual. My button view. Template button at click equals handle click. Label button template. Script setup conceptual. Import define props, define emits from Vue. Const props equals define props. Label, string, const emit define emits click button. Function handle click. Emit click button, data from button. Script. Example of a component test file, conceptual. Import describe it, expect from Vitist. Import mount from at Vue/testutils. Import my button from /src/components/my button view. Assuming path to your component. Describe my button equals. It renders with the correct label equals. Const wrapper equals mount my button props. Label click me or expect wrapper text to contain click me. It emits a click button event when clicked, async equals. Const wrapper equals mount my button props. Label test click. Simulate a click on the button. Await wrapper find button trigger click. Assert that the click button event was emitted. Expect wrapper emitted click button to be truthy. Assert that the emitted event carried the correct data. Expect wrapper emitted click button 0 to be data from button. This test renders the my button component, checks its initial text, then simulates a click, and finally verifies that the component emitted the expected event. 12.6 Beyond component testing. End-to-end E2E testing concepts. While component tests are fantastic for ensuring individual parts work, sometimes you need to verify the entire user flow, involving multiple pages, API calls, and complex interactions that span your whole application. This is the domain of end-to-end E2E testing. E2E tests simulate a real user interacting with your deployed application in a real browser. They spin up your entire application, launch a browser instance, either headless or visual, and use test scripts to click elements, type text, navigate between pages, and verify the overall outcome. Popular tools for E2E testing Vue.js applications include Cypress, a fast, reliable, and user-friendly E2E testing framework that runs tests directly in the browser. Playwright. Developed by Microsoft, Playwright supports multiple browsers, Chromium, Firefox, WebKit, and offers a powerful API for browser automation. E2E tests are slower and more brittle than unit or component tests, meaning they break more easily with minor UI changes. But they provide the ultimate confidence that your entire application, including its integration with backend services and user interface, functions correctly from top to bottom. They are often part of a complete testing strategy, used to cover critical user journeys. Adopting automated testing practices might seem like an upfront investment, but it pays dividends in the long run by reducing bugs, improving code quality, accelerating development, and providing peace of mind. By embracing unit, component, and E2E testing, You build robust, high-quality Vue.js applications that you can confidently deploy and maintain. Chapter 13. Deploying your Vue.js application. Going live. 13.1. The grand finale. Making your application accessible to the world. You've invested time and effort in building a fantastic Vue.js application. From understanding its core concepts to managing state and handling user interactions. Now comes the exhilarating part. Deployment. This is the process of taking your development-ready code and making it available on the internet so users worldwide can access and interact with it. Deployment for a single-page application. SPA, built with Vue.js, differs significantly from deploying traditional multi-page applications. Within SPA, your server doesn't generate HTML for every route. Instead, your Vue application is built into a set of static files, HTML, CSS, JavaScript, that are then served to the user's browser. Once these files are downloaded, the client-side routing, Chapter 8, takes over, managing navigation without requiring full-page reloads. This chapter will guide you through the process of preparing your Vue.js application for production, understanding the build process, exploring hosting options, and touching upon key performance optimization strategies to ensure your application runs smoothly and efficiently for your users. 13.2. The build process. From development code to production-ready files. During development, tools like Vite provide a fast and convenient experience with features like hot module reloading. However, the code you write in development, which might include many individual JavaScript modules, development-only tools, and unoptimized assets, isn't directly suitable for production. It would be too large and slow to download and execute in a user's browser. This is where the build process comes in. When you're ready to deploy your application, you run a special command, typically configured by Vite, that triggers a series of optimizations. Bundling all your separate component files, Vue files, JavaScript modules, and CSS files are combined into a smaller number of optimized bundles. This reduces the number of network requests the browser needs to make. Transpilation. Your modern JavaScript code, e.g., using async await from Chapter 10, is converted into an older, more widely compatible version of JavaScript that can run on a broader range of older browsers. Minification. All unnecessary characters, whitespace, comments, long variable names are removed from your JavaScript, CSS, and HTML files, making them significantly smaller in file size. Asset optimization. Images might be compressed, and static assets are given unique file names, often with hashes like app.f1 a2b3cjs, to enable aggressive browser caching, meaning users don't have to re-download them on subsequent visits. Code splitting. For larger applications, the build process can split your application's code into smaller chunks that are loaded only when needed, e.g., a specific route is visited or a component becomes visible. This dramatically reduces the initial load time. The output of this build process is typically a dist folder, short for distribution or production. This folder contains all the static assets, the optimized HTML, JavaScript, CSS, images, and fonts that are ready to be served by a web server. This dist folder is all you need to deploy your Vue.js application. The command to trigger this build process is usually npm run build, or yarn build, as defined in your package.json file. 13.3. Static site hosting. Options for going live. Because your built Vue.js application consists entirely of static files, it can be hosted on almost any web server or platform that can serve static content. This makes deployment incredibly flexible and often very affordable, even free for many small to medium projects. Here are some popular and beginner-friendly options for static site hosting. Netlify, a highly popular platform known for its developer-friendly workflow. You can connect your GitHub, GitLab, or Bitbucket repository to Netlify, and it will automatically detect your Vue.js project, build it, and deploy it every time you push changes to your repository. It offers features like custom domains, SSL certificates, and even serverless functions for more dynamic needs. Netlify often provides a generous free tier suitable for personal projects and small businesses. Vercel. Similar to Netlify, Vercel focuses on ease of deployment, particularly for front-end frameworks. It also integrates seamlessly with Git repositories, offers instant deployments, custom domains, and a robust free tier. Vercel is often a go-to choice for Vue.js developers due to its reputation for speed and simplicity. GitHub Pages. If your project's code is already hosted on GitHub, GitHub Pages provides a very simple and free way to host your static website directly from your repository. You configure a specific branch, e.g., GH Pages or mains docs folder, to serve your dist folder contents. It's a great option for personal portfolios, open-source project documentation, or simple landing pages. Traditional web servers, Nginx, Apache, you can serve your dist folder directly from any web server. This requires you to have access to a server and configure software like Nginx or Apache to serve static files. While offering maximum control, this option involves more manual setup and server management. Cloud storage, AWS S3, Google Cloud Storage. Cloud object storage services can also be configured to serve static websites. This is often cost-effective and highly scalable, but can involve a steeper learning curve for initial setup compared to dedicated static site hosts. Most modern static hosts are designed to make deployment as simple as pushing your code to a Git repository. They handle the build process, domain configuration, and continuous deployment, meaning every time you update your code in Git, your live application is automatically updated. 13.4 Key Performance Optimization Strategies, Conceptual. While your build tool, Vite, performs many optimizations automatically, understanding some key performance strategies helps you write more efficient code that contributes to a faster user experience. Code splitting and lazy loading. Concept. Instead of loading your entire application's JavaScript bundle upfront, code splitting divides your application into smaller, more manageable chunks. Lazy loading then ensures that these chunks are only downloaded and executed when they are actually needed, e.g., when a user navigates to a specific route or a component becomes visible. Impact significantly reduces the initial load time of your application, making it feel snappier to users, especially on slower connections or mobile devices. Vue Router supports lazy loading routes easily, enabling you to apply this optimization with minimal effort. Image optimization. Concept. Large, unoptimized images are often the biggest culprits for slower page load times. This involves compressing images without losing too much quality, using appropriate image formats, e.g., WebP for modern browsers, and serving images at appropriate resolutions for different devices. Impact. Faster image loading, which directly contributes to overall page speed. Caching. Concept. Caching involves storing copies of your application's static assets, JavaScript, CSS, images closer to the user, either in their browser's cache or on content delivery networks, CDNs. Impact reduces the amount of data that needs to be downloaded on repeat visits, making subsequent loads almost instantaneous. Modern build tools and hosting providers often handle aspects of caching automatically. Minimizing network requests. Concept. Every file downloaded is a network request. Combining multiple CSS files into one and JavaScript files into a few bundling helps reduce the number of requests. Impact. Decreases the overhead of establishing multiple connections, leading to faster loading. While these optimizations might seem advanced, simply by using modern Vue.js development practices and build tools like Vite, you're already benefiting from many of them. Consciously considering them during development, especially for larger applications, can make a significant difference in perceived performance. 13.5 SEO Considerations for Single-Page Applications. Traditionally, SPAs face challenges with search engine optimization, SEO, because search engine crawlers primarily understood server-rendered HTML. Since SPAs load and manipulate content with JavaScript, crawlers sometimes struggled to index all the dynamic content. However, major search engines, like Google, have significantly improved their ability to crawl and index JavaScript-heavy applications. Still, for optimal SEO within SPA, consider server-side rendering, SSR, or static site generation, SSG. For content-heavy applications where SEO is paramount, like blogs or e-commerce sites. Frameworks built on top of Vue like Nuxt.js, which we'll touch on in the next chapter, can render your Vue components into full HTML on the server before sending it to the client. This ensures search engines receive fully populated HTML, making indexing much more reliable. Dynamic rendering, serving a pre-rendered HTML version to crawlers while still serving a client-side rendered SPA to users. Clear meta tags, ensuring each page in your SPA has unique and descriptive meta title and description tags that are updated dynamically as routes change. Vue libraries are available to help manage this. Sitemaps, providing a sitemap XML file to help crawlers discover all your application's URLs. For typical B2B applications, dashboards, or internal tools where deep SEO isn't a primary concern, a purely client-side rendered SPA is usually sufficient. Deployment is the exciting culmination of all your hard work. By understanding the build process, leveraging appropriate hosting solutions, and having an awareness of performance best practices, you can confidently share your Vue.js creations with the world, providing your users with a fast, engaging, and modern web experience. Chapter 14, Beyond the Basics, the Vue.js ecosystem and your next steps. 14.1, The ever-expanding world of Vue.js. Congratulations! You've journeyed through the fundamentals of Vue.js, learning how to build components, manage state, communicate with APIs, and even deploy your applications. This knowledge forms a robust foundation for building interactive and dynamic web experiences. However, the world of web development, and particularly the Vue.js ecosystem, extends far beyond these core concepts. Vue's flexibility and welcoming community have fostered a rich collection of tools, libraries, and frameworks that can further enhance your development workflow, solve specific problems, or expand your application's capabilities. This chapter aims to provide you with a glimpse into this broader ecosystem and offer guidance on how to continue your learning journey. 14.2, Meta Frameworks for Advanced Use Cases. Nuxt.js. While Vue is perfectly capable of building single-page applications, SPAs on its own, certain demanding use cases, especially those requiring strong search engine optimization, SEO, or faster initial page loads, benefit from server-side rendering (SSR) or static site generation (SSG). This is where Nuxt.js comes in. Nuxt.js is often referred to as a meta framework built on top of Vue.js. It provides a powerful and opinionated scaffolding for universal Vue applications, meaning applications that can be rendered both on the server and in the client's browser. Nuxt simplifies the complex configurations usually associated with SSR and SSG, allowing you to focus on writing your Vue components. Key features and benefits of Nuxt.js include server-side rendering (SSR). For each page request, Nuxt can render your Vue application on the server and send fully formed HTML to the browser. This means users and search engine crawlers get a complete page immediately, improving initial load times and SEO. The Vue application then hydrates on the client side, making it fully interactive. Static site generation (SSG). Nuxt can pre-render your entire application into static HTML, CSS, and JavaScript files at build time. This is perfect for content-heavy sites like blogs, documentation, or marketing pages, as the resulting static files can be served from a CDN for lightning-fast performance and excellent SEO. Zero configuration or minimal. Nuxt comes with sensible defaults and conventions for things like routing, data fetching, and state management, providing a highly productive development experience without extensive manual configuration. File system routing. Nuxt automatically generates routes based on your file structure, making routing intuitive and easy to manage. Module ecosystem. Nuxt has its own rich module ecosystem, offering solutions for everything from authentication to internationalization. If your project requires enhanced SEO, better performance on the initial load, or a more structured approach to large-scale applications, exploring Nuxt.js would be a natural and powerful next step. 14.3 UI Component Libraries. Accelerating design. Designing and building every UI component from scratch can be time-consuming, even with Vue's component system. UI component libraries provide a collection of pre-built, production-ready Vue components that implement common UI patterns, buttons, forms, navigation, cards, etc., often following a specific design system like Material Design or Ant Design. Using a UI component library offers several advantages. Speed. Rapidly assemble interfaces using prefabricated, well-tested components. Consistency. Ensures a consistent look and feel across your application without extensive design work. Accessibility. Many libraries are built with accessibility in mind, providing components that meet industry standards. Responsiveness. Components are often designed to be responsive out of the box, adapting to different screen sizes. Popular UI component libraries for Vue.js include Vue.js, a comprehensive material design framework for Vue, offering a vast array of components and customization options. Element Plus, a desktop UI toolkit for Vue.js, providing a rich set of components, often used for administrative dashboards. Quasar Framework, a high-performance, full-fledged framework that allows you to build not only spas, but also mobile apps, iOS and Android with Cordova/Capacitor, desktop apps Electron, and even browser extensions from a single codebase. Naive UI, a popular, fast, and feature-rich Vue 3 UI library. Choosing a UI library depends on your project's design needs, performance requirements, and whether you prefer an opinionated system or something more flexible. 14.4 Headless UI libraries, control over styling. Sometimes, you want the functionality of a UI component, like a complex drop-down menu or a modal dialog, but complete control over its visual appearance. This is where headless UI libraries come in. They provide the accessibility, interaction logic, and state management for common UI patterns, but leave the styling entirely up to you. Instead of pre-styled components, you get unstyled, accessible primitives that you can style with your own CSS, utility classes, like Tailwind CSS, or CSS and JS solutions. This gives you maximum flexibility to match your brand's unique design system without fighting against a library's default styles. An excellent example in the Vue ecosystem is Headless UI, from the creators of Tailwind CSS, providing fully unstyled, accessible UI components. 14.5 Utility Collections and Composables, Vue Use. As you build more complex applications, you'll encounter recurring patterns or common utility functions. Vue's composition API naturally lends itself to creating reusable pieces of reactive logic, known as composables. Vue Use is a popular collection of essential Vue composition API utilities. It provides a vast range of composable functions for common tasks, such as working with the browser's DOM, e.g., use scroll, use event listener. Managing state, e.g., use local storage, use session storage. Handling animations and transitions. Utilities for working with time, arrays, and numbers. And much more. By leveraging a library like Vue Use, you avoid reinventing the wheel, leading to more concise, readable, and maintainable code. 14.6 Your next steps. Continuing the learning journey. Learning Vue.js is not a destination, but a continuous journey. The web development landscape constantly evolves, and staying curious and engaged is key. Here are some suggestions for continuing your growth. Build real projects. The best way to solidify your understanding and learn new patterns is by building things. Start with a personal project, contribute to open source, or even volunteer your skills. Choose projects that slightly challenge your current knowledge. Explore the official documentation. Vue.js has exceptionally well-written and maintained official documentation. It's an invaluable resource for deep dives into specific topics, understanding best practices, and staying up to date with new features. Engage with the community. Vue.js Forum and Discord. These are great places to ask questions, help others, and stay connected with the community. Follow key developers. Many core Vue.js team members and prominent community leaders share valuable insights and updates on social media platforms. Local meetups and conferences. If available, participating in local groups or attending conferences can provide networking opportunities and expose you to new ideas. Dive deeper into JavaScript. A strong understanding of modern JavaScript, E6+ features, asynchronous programming, Modules will only make you a more effective Vue.js developer. Learn related technologies, backend development. Understanding how backend APIs are built will make you better at integrating with them. DevOps/deployment. Digging deeper into CI/CD, continuous integration, continuous delivery, pipelines, Docker, and serverless functions can broaden your perspective on taking applications from code to production. State management, advanced Pinia/Vuex patterns. For very large applications, explore advanced patterns with Pinia or dive into Vuex if you encounter legacy projects using it. Testing. Continuously improve your testing skills beyond the basics. Your journey with Vue.js has just begun. Armed with the knowledge from this book and a continuous learning mindset, you are well equipped to build powerful, elegant, and maintainable web applications for years to come. Happy coding!